Okay, today actually we will be talking about this chapter 9, section 4, starting for graphing for actually sine and cosine function. Okay, and this one actually, let's do this. Here, we started from the unit circle. Last time we talked about this unit circle. Okay, we talked about this unit circle, and for any angle, we would have a theta. We would have this one. How long is this one? The arc.
It's the radius times the angle.
Radius times the angle, so it's r theta, right? And then here we have the sine theta and cosine theta, right? Mm-hmm. So the sine theta should be 1/2. Cosine theta would be square root 3 over 2, right? So that's the basic idea of this. And then when the theta grow over 190 degrees, you will have a reference angle here. So actually reference go to here. And then here we will have reference then go to here. Here we will have reference angle to here. And same thing in the first quadrant, it should be something like this, right? So basically you try to use this unit circle to create the possible reading for your angles sine and cosine, right? Now, today, actually, we are going to do the next thing. It's called unwrapping the unit circle, and we will also unwrapping for the cosine. So right here, say if we have this big unit circle over here, right? And then we started to try to, let me put this here. Okay, put this guy here. Let me put this guy here. And then have this guy over here. So we started to work on our reading for sine. So basically right here we have the x equals 0. And this one, let's assume this is x or theta. Let's assume this is theta. Then the first one, when we have, say right here we have pi, here we have 2 pi, and then here we have half pi, and then here we have actually 1/6 pi, 1/3 pi, 1/6 pi, right? So the first one we have a reading is 1/2 for sines. Sorry. I should have this over here. And then I have this. So right now, we would have this point coming to here to 1/6 here. There's a point. And then 1/3, this one over here. We draw another point. And this one 1/2 over here. So another point. Right now, I change color to blue. And then I continue to draw this 2/3 point. This 2/3 point, I should have a 2/3 point. Actually, is over here. And then I have 6 point. It should be here. And then my pi will be here. So basically, I will connect this. It will look like this, right? And here we have 2/3 pi. The point should be here. The height over here will be 1 because this one is actually the maximum value. It should be 1, and it's actually sine half pi. And this lowest point, the valid, this one sometimes we call it peak. And this one we call it valid. The valid point actually is -1, and the angle is here. The angle is right here. So it will be here, a blue point. If you connect it to here, and then here you have, right here you have 1/6 pi. It should be right here, a point. This 4/3 pi, it will be here. So it will be going down like this and going up and continue. So this one actually show you basically, this one show you our unwrapping for sine wave. So sine wave look like this, going top, and then the baseline, this one middle with baseline right now is actually 0. And then the peak is 1. What happened in half pi, and then 2/3 pi, and 3 half pi actually is actually the valley point is -1, and here's 1. And this one we call it, the unwrapping of unit circle for sine. Okay, this one's called unwrapping for sine. Okay, now let's go back to cosine. Let's go back to cosine. Let me clean this as well. Now let's go back to cosine. Let me try to do this. It doesn't matter actually. Let me put it up. Now we are doing cosine now. So let's do the red one as well. Okay, so right here we have this one. Sorry. We have this one. Okay. And then we print out this one as well. Okay, so right here, we try to draw this scene, same thing. You have pi over here, 2 pi over here, and then our 0 is over here. So actually at 0, cosine is like this. So we end up with 1 over here. And then next one is actually what is 1/6 pi. It will be here. It's 2/3. Actually square root 3 over 2. Right? And then right next one's 2/3 pi. It will be 1/3 pi will be here. And then right here is actually from here to here. And then this one, half pi, it will go to 0. So basically it's something like this. And then when it is pi, it will be going to -1 over here. So you'll be going like this, going up to here, to here. Here is 1. Okay, but now let's draw the sines back as well. Sine 1. For sine 1, it started from here. I'm sorry. Started from here, go up to 1, going down, touch here, minimum over here, going up to here. So blue one is sine, red one is cosine. Any questions so far?
No.
So the sine reading is by this, cosine reading is by this, by this, by this. Sines by this. Okay? And then from this chart, we know what? Actually, sine is cosine. Sine is actually cosine moving to the right for half pi, right? And then here, going half pi will be here. Here, going half pi will be going here. Going half pi will come into here. Here, going half pi will be here. Okay, we know the relationship. First, we have the drawing for red one for cosine, blue one for sine, and then we have this movement of this to here. So first equation, then we just remember this chart. Let me actually here, let me just cut this. Let me take a picture. Okay, now I'm going to erase it. Okay, the red one is gone. Let me see. The red one, going back for the red one. So now let me use the black one. Okay, now we have a triangle. We have a triangle. We have a triangle. Here is theta. Here is phi. So this one R, this one actually is A, this one actually is, I'm sorry, this one's A, this one's B, right? So cosine theta, let me clean this, okay. Let me clean this. This one is not convenient. Let me clean this. Let me resolve this whole thing. It's not convenient. Let me clean all of these. Okay, and then close this. This one go to rest. Now let me use the whiteboard directly. So for our chart, let's use the black color, and we have this. We have this line right here, and then we have the red one for cosine going down to here, half pi for pi over here, 2/3 pi, and 1. And cosine on this side, going down, going to here, going up, make the top. So actually it's an even function for cosine. And for sine, it actually is an R function. R function is going this way, going here, going down, going to here, and then actually going up to here. And this one going down up to this point is the lowest point, going up to here, going up to here, maybe the top over here, and going down. Okay, that's a sine and cosine. So blue is sine, red is cosine, and then we have a triangle. Let's have the triangle right here. This one we have theta. This is R, this is B, this is A on our unit circle. So actually, this one cosine theta will be, cosine theta is cosine theta, will be.
Oh, the radius over. Wait, no. The adjacent side over the radius.
Yeah, so actually it would be A over R, right? But here we have a phi. And then this guy actually, it should be a sine over here. So actually it's also what? This is equal
A
to
over R.
It's actually A over R is sine what?
Phi.
Half pi minus phi.
Oh.
I'm sorry. Actually, this one should be equals sine phi, and sine phi is cosine. Let me see. Actually, sine phi. So cosine theta is sine phi equals sine half pi minus theta. So cosine theta is sine half pi minus theta. That's one relationship, right? And another one, at the same time, we have sine theta is from here to here. It's actually equals B over R. It is also equals cosine phi because it will be, this phi, it will be cosine phi So it should be actually cosine half pi minus theta. So here are two relationships. One is cosine equals the sine half pi minus theta. Sine theta is cosine half pi minus theta. So please write down these two equations. The cosine equals sine half pi minus theta, and sine theta equals cosine half pi minus theta based on this triangle and this chart and this chart. So copy down the purple equation and this pink and red equation on your notebook, and also this triangle. Okay. Same thing for Christopher. Okay.
Yeah.
That's the first rule. First rule for this relationship between sine and cosine. When you are done, let me know.
I'm done.
Okay. Now I'm going to teach you the second rule. This rule, the reading is by, let me clean this. Okay. This first rule, we have a triangle. Let me draw the triangle bigger. We have one triangle, bigger triangle. That is, we have a theta, we have a phi. So cosine theta equals sine half pi minus theta, right? And then sine theta equals cosine half pi minus theta. I'm sorry, theta. This one is theta. So basically, this one and this one, the sine and cosine are changing. The sine for this guy is the cosine for this guy. Cosine for this guy is the sine for this guy. That's what these two rules say. Okay? Mm-hmm. Now the relationship between the angles. Now let's go back to the previous one. The previous one we have here, and we have this. We have the red color, cosine theta like this. We have the blue color for sine like this. So the relationship is cosine theta, and this one is the same. What's this? This one is sine theta minus half pi. So this one is the same. So sine is leading by half pi. Remember that equation, previous equation. Previous equation is what? Cosine equals sine half pi minus theta. But this one is what? These two are the opposite, right?
Mm-hmm.
Yeah?
Yeah.
They have the same value.
I think they're opposite. Wait, actually, I think they're the same. Actually, wait, I think they're different.
Different or the same?
Different?
Let's see. Okay, here we have this 0, 0, 0, 0. Wait. Okay, this one should be, I'm sorry, this one should be plus sign, right? Mm-hmm. So 0 sine to be half pi, yeah. So this one actually sine theta equals cosine theta minus half pi. It's cosine moving by right, half pi. Okay, so here this one's plus sign. I'm sorry, I made a mistake. So there are two rules. The first rule is by the triangle is like this. And this one is by graphing. It actually, sine is actually moving, actually cosine moving by half pi to the right is your sine. And sine moving to the left for half pi, that's your cosine. That's these are two new rules. The first two rules is sine theta equal cosine half pi minus theta. These are the previous two rules. And here we have another two rules. The cosine equals sine theta plus 2 pi. And here actually sine is leading cosine by this half pi. So actually sine moving left for half pi will be equal to cosine. And this one, cosine moving right, half pi will be sine. So copy down these two equations. And then these two you already copy down. And these two are from what's the angle name? Theta and phi are what? Complement angle or what? What's the name for theta and phi?
Complementary.
Complementary?
That's what I thought.
What's the complementary angle? That's the name. So for the complementary angle, yeah, so for complementary angle, actually, your sine will become the cosine of its complementary angle, and then sine's value will be the cosine's complementary angle. And then in terms of graphing, sine is leading cosine by half pi. So sine moving to the left by half pi will equal cosine. And then cosine moving right for half pi will be sine. Okay, these are the two rules you need to remember. It's always been very important when you try to prove the equation. But here, I just show you the graphing relationship. But later, I'm going to show you in this presentation part. Let's look at the transformation part. Let's look at the transformation property of the sine and cosine. We have the relationship in this transformation part. So just copy down these two equations and let me know when you are done. I'm going to erase it.
Yeah.
So here we finish this graphing for unwrapping the sine and cosine. We finish this part. So you should be able to do this for sine and cosine. Sine is a odd function, cosine is a even function. So now the next one we will look at is the stretching for sine and cosine. Okay, now let's go to the transformation of the functions. Are you done with this?
Yeah.
Let me take a picture. So are you okay, Ashley? Hello? Wait, she's gone.
Yeah.
Okay, you're done, right? Okay, now.
Yeah.
Let me clean this. Okay, these are by graphing and by the complementary angle. Now the next one we are going to look at is the transformation of the functions. And for transformational functions, it actually is called a child function. Every function has a parent function. Say the basic parent function would be for a line. For a line, the basic function would be y equals x. That is a basic function. Then we start to add something in there. We start to add like y equals mx plus b. So this b is a baseline, m is a slope, but it actually also for amplitude. So originally we have y equal x should be this one. And then we make it bigger for m ratio. So you move up by a ratio of m, you got this line. And then if we move up by b, this line, again, we move up by b, this b will be this intercept, y-intercept, that is this b. So this is a slope and the intercept form for a line. But so basically, the original form, we call it parent function, is like this, y equals x. And then the child function derived from the original function is like this. So the original function is this line. And then we actually, is this line. And then we make a ratio of m up to here as a second line, and then we move up by b. So basically the transformation starting from y equals x, then we have a ratio of m on x, and then later we move up by b. So this one is called amplitude. The m, we call it amplitude. And then the b we call vertical shift. So this chapter right here, we try to study the relationship among the functions, and we will also use it for trigonometry functions. Okay, so green this, that's the child function, child graph. So now the next one. The next one is the overview of transformation. We may have absolute value, refraction, stretching, shrinking, and translation, and last one is rotation. Okay, these are the topics for transformation. First one, absolute value. Okay, here is the different transformation curve. So the first one, if you move up, you add a, you move up, that's first transformation, that's called translation. Up. And minus a, you go down. If here you have minus, if here you move down, you will have a minus a. And then here is refraction. Basically, you got your minus value for that function. And if you have a stretch moving up, that's your amplitude. You make it taller. You actually stretch in the y-axis. We call it stretching y-axis. And if you make it wider, then that actually is wider. That's actually called x-axis stretching. And make it smaller, we call it shrinking. And then if we move to the right, we call it shifting. And then if we, actually this one is reflection to the y axis, it should be mapping to here, or here mapping to here. That's the reflection to the y-axis. And then this one is stretching in the x-axis, so move it wider, make it wider. This is this, okay? So these are basic move up, move down, move left, move right, reflection, and stretching. And we are going to talk about the relationship for these different operations and functions. So the next one here is a very simple, later I'm going to send you this. It's a very simple transformation rule. So if my function move up by d unit, my y would add d. Okay, let me actually keep this here. And then I have this, make it smaller. And let me put it on the side. Okay, right here. The first rule, I have a function. It is something like this. and I move up by t. I move up by t, so the function will be like this. Here is the t, is this t. It's actually this t, right? If I move, this is move up. If I move down by t, it will be y minus t. Okay? And then if I move right, actually it should be, the x should be, so this one this one is, actually this one is f of x, right? Say equals x squared, right? This one will be x squared plus t, and this one will be x squared minus t. Now, if this one moved right by c, then it's what? It's actually x minus c squared plus t. So this one is moving to the right. Your x should minus something. Okay? Your x should be minus something. But if you move to the left, you move to the left to say right here, the function move to the left by c, here to here is c. Your function should be x plus c squared plus d. This one is no d, it's actually original form. Okay? So the sine function we just talked about, we have a cosine, right? And then we have a sine function that is. So cosine move right by half pi. So this original function is cosine theta. And then this new function should be cosine theta minus half pi. And this one is, after moving to the right half pi, it should be sine theta. So that's the function we got. Okay? And then your original form is like this one. It's called sine theta. And sine theta move to the left by half pi. So sine theta move left by half pi should be plus half pi. And this guy is actually becoming cosine theta. So it actually got the cosine theta. That's the two new rules that we mentioned about in the previous slides. So right here we have moving up, moving down, moving right, and moving left. And the coordinate, the value of your coordinate point, x should go up, x no change, y plus d. Go down, x no change, y go down by d. And then moving to the right, actually x minus c, and moving to the left, we plus c. Okay, these are the basic transformation we have here. Can you copy down these two charts? Actually, let me make a copy for you. And then you try to write down these two and think about that two rule: moving up, moving down, moving right, moving left. Write down your function. For example, you all using this s squared function to write down the four operations: moving up by d, moving down by d, moving right by c, moving left by c. And putting the sine and cosine figure after it. This show you the first translation, transformation, and translation is the first transformation, or shifting. Some book would say shifting. Moving to the right or moving to the left, we call it horizontal shift. Moving up or down, we call it vertical shift. So let me know when you finish these two charts. So first one, you need to use the unit circle, unwrap it, you get your sine and cosine. And then after that, you need to know when you move up, move down, move right, move left, what will happen to your x and y. And the x and y change will be on this chart. So later I'm going to send you this file, and you can also find it from this course on my. You should also be able to find it from here. You should also find it from that Python course. This one, you should also find this. The transformation is on the chapter 6 over here, functional transformation. Okay? So remember, there are two rules related to the complementary angle of the triangle. And then here, two more rules by shifting to the right and left for sine function and cosine function. Are you okay? Can I remove it?
Yeah.
How about HD?
Yeah.
Okay, let me clean it. Now, let's look at the summary for the sine and cosine function. Since we are doing this shifting, so let's make a plot. Okay, make a plot, and this one, this is ugly. I should draw straight, but this is not straight enough. Okay, now let's go this. We have a straight line, and we have this, and we have the first function cosine in red. It's coming from here, going down to here, going down to here, going up to here, going up to here, going down here to here. That's cosine. Second one, we keep the color for blue. That's sine. It's like this. It's like this. Okay. And this side going here, going up to here, going up to here, and going down to here. Now the third color we use purple. The purple is another one that actually is leading sine. It's starting from here to here to here, going down to here, going down to here to here. And this one is going to here, to here, to here, to here, to here. What's this? What's the purple one? The red one is cosine. Red one is cosine. And then, let me see. Red one is cosine. Let me put it here. Red one is cosine. Blue one is actually sine. And then how about the purple one? Purple one is what? Purple one is minus cosine. And then the last one, that's the one that's pick what? Brown one. Brown one is the last one. It even leading the purple one is going this way, this way, this way, this way, this way, this way to here, this way up to here, 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 to here. And this one is called minus sine. You know why I'm doing this? Why I'm doing this relationship in this one? Cosine, sine, minus cosine, minus sine to here. Isn't this similar to our chart of 1i minus 1 minus I? Is that similar to this? Cosine move to the right for 90 degree, that become a sine. Sine move right to 90 degree, become a minus cosine. Minus cosine move right 90 degree, become a minus sine. Minus sine move to the right for 90 degree, become a cosine. And then cosine move left 90 degree, become a minus sine. Minus sine move left 90 degree, become a minus cosine. Minus cosine move left 90 degree become a sine. So the only thing you don't need to remember that many things when you look at the who moved left or right for 90 degrees. Just remember this chart. Is that okay? So let me copy this down. Just remember the chart I drew at the bottom. I'm going to explain that one, but remember that one. That is easy and understandable, very easy to remember format. Okay, this one I will also copy to Christopher. Okay. So now, remember the plotting. First, you need to come up with the cosine. That's number one, because it started at 1. The location is 1 over here, right? Moving 90 degree become I. 90 degree is sine, right? Moving 90 degree become -1 as a minus cosine. Sine is 1. Cosine is 1 minus cosine minus 180 degree, and then the third one is minus sine. Okay, that's actually erase this. So the relationship you need to remember actually is cosine, sine, minus cosine, minus sine. So actually moving 90 degree to the left. So cosine theta moving to the left, half pi will become sine theta, right? Now, I have a question. Cosine moving to the left, this much, 3 pi over 2 will be what?
Negative sign.
Yeah, it will be negative sign. That's how you use this. Got it? So cosine theta minus 10 pi. What's that? That's still cosine because it's 2 pi multiple of 2 pi. But cosine theta minus 15 over 2 pi. What's that? Every 2 pi, you take it out, right? So basically, what's that? 2 pi will be 4 divided by 4. So actually, it will be minus 12 taken out. So it's actually the same as this. It will be minus sign. Is that okay? Your minus 15 pi taking out minus 12 plus plus 3 over 2 pi. This one cancel out. So it's actually minus 3 pi, right? It is okay?
Yeah.
That's a fast way to convert some function. And just remember this cosine, sine, minus cosine, minus sine chart. Are you okay, Ashley, with this? Yeah. So that's a fast way to remember the your transformation, moving to the right, moving to the left. Now let me clean it. Do one more exercise. Now we have this. Still, we have cosine, sine, minus cosine, and minus sine. Now here we have minus sine theta plus 7 over 2 pi. What's this? What's this function for single function with something here? Theta, actually theta, just single function. What is the function f? It's actually what? Moving to the left for 2, 7 pi, right? So if you have 4, that is actually 2 pi. So this guy is actually plus, also plus 2/3 pi, right? You take 4/2 out, right? That's 2 pi. So you're starting from here, taking 2/3 pi, that guy is cosine. So this f is cosine. Is that okay?
Yeah.
Because this guy, 7/2 pi equals 2 pi plus this 3/2 pi, right? So this one, 2 pi actually is just being taken out. It's a whole cycle. Is it okay for you, Ashley?
Yeah.
So this actually, the beginning part, I just try to tell you how to unwrap the function. After you unwrap function, you should come up with this idea, and fast you can calculate how you translate the function real quick with the 4 possible functions. Okay.
Well, I have a question.
Yes.
So, if it's negative sine, does it go clockwise instead of counterclockwise?
Negative sign
Yeah.
with something in here. It doesn't matter. Your original form is minus. It's this guy. So moving left always go in this.
Okay.
So this one is just a F. It's nothing special.
Okay.
Okay, it's nothing special. Now let's do this. If you don't believe this, let's clean this. If you don't believe this, let's do this. Okay, we started from here. We have a sine function is this. Sine function is like this, right? And we can have a minus sine function is actually minus, right? It should be something like this, right? And then minus sine function, we move by actually what? How much? We move by 1, 2, 3, 4. That's here is 2 pi, right? And then 1, 2, 3 up to here. So this guy is up to here. So basically, we move this this guy from here. We move here for 2, 7 pi. It should be something like this, like this, like this, like this, like this, like this, like this. Okay, this guy is cosine, right? This is sine. This one is sine. The red one is minus sine. The minus sign move to the left for 2, 7/2 pi. So this point should be here. It should be going this way. The same with this, right? And then you trace back. Oh, okay, here is cosine. So my theory for having this minus sine, minus cosine, sine. Here, this one is just a f of x, right? And for f of x, I have plus 2, 7 pi, 7/2 pi. This one is actually moving to the left by this much. So I don't care here is sine, cosine, minus cosine. It doesn't matter. It's just a function. It's just a function. Don't change your way of rotating. The rotating is based on this plus sign. Plus sign starting from here, 3/2 pi is going to here. No matter what function is outside here, it doesn't matter. It just tells you the initial point. What is the initial point you get started from? Is that okay?
Mm-hmm.
Yeah, I don't know what I was doing.
What?
No, I just messed up on one part.
You still don't understand?
No. It was just one part. Like, now I understand.
Okay. So basically, just treat yourself like a machine. Okay, you don't need to think too much. Don't need to think much. The most important part is remember that relationship. Okay, then you now this time that you do exercise. Okay, now you guys do exercise. You guys bring up a white paper. Now we still have this cosine, sine, minus cosine, and then minus sine over here, right? Now let me have a minus cosine theta minus this much. What is the function f? What is the function f now?
Wait, what am I supposed to say?
Well, what is the function f?
Wait, do you want me to say f of?
F is what? Is one of these four. Which one?
Oh, negative sine. Actually, I'm not sure.
Positive sine.
Positive sign. Say right here, you have this one. 5 over 2 pi equals 2 pi plus half pi, right? So you turning what? Turning right for half pi. Turning right for half pi is what? You starting from here. Wait, actually it's a minus sign.
Oh.
Bro, let's go. Easy.
Okay. Let's check. Let's check. Okay, I don't know. Let's check. Don't be happy now. Okay. Let's check. I'm sorry, this one's blocking all of you. So that's why I want to have some exercise. Okay. We will have one more. Okay. We will have one more. Now let's check. We have the minus cosine, and then we have the minus cosine. First, we need to have the minus cosine. We know cosine, so minus cosine is here, the lower point. Come to here, go to here, right? And then keep going to here, right? Now this one moving right by up to here is 2 pi and 2 half pi. So here is the lowest point. Coming from here to here, coming to here, going to here, going to here. Okay, who is this guy? It's a minus sign. Okay, so that this remember this one. It never fail. Okay, it will never fail. This one will never fail. Okay, and I told you this one line here is for shifting translation. This one is also good for taking differentials. Let me show you. Taking a derivative for sine and cosine. Okay, so here we have the table. Sine's derivative is cosine. Cosine's derivative is minus sine. Minus then we know. Then we know here. Then we know here. Okay, let's go back. Let's go back to here. This one, both of you got it, right? Let me copy this for you. It's not only used for translation of the angle. It's not only used for that, okay? It's not only used for that. It's also good for taking derivative. And what is derivative? Derivative is the slope. Okay, so right here we have cosine, sine, minus cosine, and minus sine. So when we have d sine dx equals cosine, so taking differential going to here, and this one cosine is the slope for sine function. And then cosine's slope is minus sine. So this one is taking derivative. This way, taking derivative, going this way, taking derivative, going this way. And then what? Also is a shift left, right? And then here, this way, taking integral. And is shift right. So all these four functions, taking derivative, taking integral, shift left, shift right, can all be represented by this chart. So remember this one. This one is probably most powerful thing you will do. Taking derivative for sine is cosine. This cosine's derivative is minus sine. Probably actually doesn't know what's a derivative, right? I'll explain it. It's very simple, okay? Derivative is very simple. And it will be very simple and easy to remember. First thing is, let me just copy this for you again. We have one more relationship called derivative and integral. Derivative is actually very simple. It's just the slope of the function. It is actually the slope of the function. And it's actually being told in what? It is told in calculus course. Now let me clean this up. Clean this right part up. Okay, I clean everything. It's okay. Now let's have this. We have this guy called cosine function. Clearly, right? This one's cosine. And then we have this chart, cosine, sine, minus cosine, minus sine, right? Now, what's the slope for this? What's the slope for this?
0.
0, right? How? Okay. We have a 0 here, right? What's the slope for this? It's almost like a minus 1, plus 1, or minus 1, minus 1, right? So minus 1 is over here. And then what is the slope for this? It's again, it's 0. What's the slope for this? Here is plus 1. So actually it's something like this. So who is this function? This is minus sine. So taking derivative, the slope is like here. Actually, are you all following?
Yeah.
So it's just like we draw a line. This line is called derivative. So at this point, the slope of this horizontal line is 0. So we got the 0 over here, right? And at this point, we have minus 1 going through, minus 1. So here is minus 1. And in this point, we have plus 1. So it's plus 1 right here. I'm sorry, here is 0 over here. So when you put a chart, actually the slope function for cosine is actually minus sine. And then slope function for sine is cosine. Slope function for this is this. That's called taking derivative. And it's actually in the same angle for you to shift. It's the same like you are shifting left. It's the same like you are shifting left for 90 degrees. Shifting left for 90 degrees. It's the same as you take derivative. And then this side is called integral. This side integral. So here, if you check the area here, right? Here is starting to be 0. And after here, the whole area for this guy, is 1. So actually, at the 90 degree, here is 1. Starting from 0, you go up here. And then after 90 degree, you got negative area over here. Until this point, you got minus 1. So here you have minus 1. These two cancel out. So actually going down to here. So the whole area drop down to 0. And then keep going like this. So the integral of cosine becomes sine. It's integral. Integral is counting the area under this function. Okay, but this it's too far. Okay, it's too far. But integral the same as moving to the left. So this chart, the only thing I want to say here is the relationship between all of these functions. Is the relationship for all of these functions. It had two ways to use it. It had two ways to use it, and maybe later when you are 11th grade, you take the calculus, you will know how powerful this is, and also it's also useful for physics. Okay, remember this chart I drew today. It will be very useful even when you go to college. The only thing you need to know about sine and cosine is this chart. The summary for sine and cosine transition is this chart: cosine, sine, minus cosine, minus sine. Moving left, moving right, right? It's a right. It's counterclockwise. Right, right, left, right? And then this one here is taking derivative for its slope. This way is to taking integral. That's it. Four things you need to know for sine and cosine when they are in transition. I know the integral and differential the derivative are too much right now for both of you, but just remember the chart. For the time being, you just need to have the shift left and shift right. Shift right, you go counterclockwise. Shift left, you go clockwise. Okay? That's the only thing you need to remember right now. That's the first transformation we have. The next one is refraction. Refraction is what? Just like your what? Refraction is just like your even function, right? You have put a minus x, y over there. And then refraction on y angle, y axis, you just put minus x in for x, okay? And vertical stretching. So now we have a vertical stretching and horizontal stretching. Vertical stretching and vertical compression. Compression is shrinking, okay? And then horizontal stretching and horizontal shrinking. Now, let's look at these two issues. Say I have a function. This one I am sine function, right? This one is sine function. So this one is sine x, right? And then vertical stretching, I doubled it like this. We actually put 2 in here, right? So this one is the vertical stretching. And this one is actually equals, is actually called y, right? That's called vertical stretching. So if this one is actually half, then you have vertical shrinking, only half of it, okay? But the vertical shrinking. So actually this factor, A, if A's value greater than 1, you go up. A's value less than 1, it goes down, it becomes smaller. That's the vertical stretching and vertical shrinking. Or sometimes the shrinking is called compression. So far okay for Ashley? Are you okay?
Mm-hmm. Yeah.
Okay, this one is called vertical. Now let's look at the horizontal part. Let me clean it. Horizontal part for the translation is easy. horizontal part for translation is easy. We have a sine f of x equals y equals f of x is sine theta. And then we move up d, so here we plus d. Okay, this one move up. And then we move down, we have minus d. It will be sine theta minus d. So this is very easy, okay? The translation for vertical part is easy. So let me just finish this up. Previous one is horizontal shift, okay? Previous one minus c to the right is actually for the x part. Now it's for y part. Now let's look at the horizontal compression or horizontal stretching. For the horizontal part, it's the same. It happened on the x part. Okay, it happened on the x part. So right here, I have a sine function like this. I call it f of x equals sine x. That is y. Then I have a function called the green one. Actually double the speed. So here I have one cycle. Here I have one cycle. Right? So this one we call it y equals f of x equals sine 2x. And this 2, we call it frequency. So sometimes we can also write sine frequency x or a b over here. That's frequency. Now it makes it faster. So for ax in sine, is a when a greater than 1, make it faster because it's called frequency. Is that okay? It's called frequency. So now if this f is half, okay, then we have sine half x. Then that guy actually is like this. Okay, keep going. Okay, that one is actually only half the speed. So the from here to here we call it period, and period actually is 1 over frequency. So frequency means like one cycle, 1 second I can have how many cycles. Period is like 1 cycle I take how many seconds. Is that okay? So right here the period, the normal sine, the period is 2 pi, right? So if I double it, my frequency actually, my period is actually only half pi. 1 pi, I'm sorry, 1 pi. But my frequency will be 2. Here I will have 2 over here. Okay, let me take the picture and then explain. This is called horizontal stretching. It's called horizontal stretching. So we have this one. Actually, let me draw this smaller. It'll be something like this. It's called sine x, right? Now I have another guy. It double the speed. So from here to here, it's called a period. So this standard form, the parent function form, the period is 2 pi, right? And if I have a blue one, I only use half of the period. Pi, this guy is like this, and then that guy actually is sine 2x, and this one is 2 is a frequency, and it is 1 over the period. So period is 1 over frequency. frequency is 1 over period. Frequency is how many cycles per second, and period is 1 cycle for how many seconds? For how many seconds? Yes. Is that okay? That's the definition for frequency and period. But this is a standard form. This one is a standard form. 1 cycle right now is 2 pi. The period for sine 2x is actually pi. So here, the frequency for this one is actually 1 over 2 pi. That's the frequency for this standard sine x. This one, sine 2x, the frequency is 1 over pi. And then if we have a real one, it's so-called vertical compression. It's something that is way slower. That guy is called sine half x. So the frequency is only 1/2. So period actually 1/2. The frequency is 1/2, and then I'm sorry. Let's look at it. The period actually is 4 pi now. So frequency is 1 over t. It's 1 over 4 pi. So here we have 1 pi, 2 pi, 3 pi, 4 pi, all out of the chart. That would be the period for this very sine function. That's called horizontal stretching. And the blue one is horizontal compression because you make it more dense. But actually frequency is faster for blue one. Is that okay so far? Now we finish this this one. We have the compression stretching for all them done. We have the basic transformation rule done over here. Okay. Now before we go into some other topic, let's check Ashley's textbook. Okay, here we have the shrinking and stretching for sine and cosine, right? So this factor A, what's the A? A is the amplitude. So it's like vertical stretching or vertical shrinking. When A greater than 1, it's vertical stretching. A absolute value less than 1, that's vertical shrinking. But -5 is actually still stretching. It's just what? It's just a reflection on the y-axis, but the total amplitude is still going up. So the amplitude is the absolute value of the A, right? Say right here, I have a sine function. I have a sine function like this, right? But at time -1, it actually like this. There's no stretching or compression. But if I time -2, it is actually stretching because it's becoming like this. So the A is this ratio, A is this ratio, A is this ratio. When A equals 1, it's a typical sine function, but A equals -2, it will be like this. So that's the amplitude. Period is what? 2 pi over B absolute value. So this one is a frequency, and it will be 2 pi over B. So when we have a standard sine x, A and B both are 1. B equals 1, so the period is 2 pi, right? If the B is 1, it's actually 2 pi. But when B equals 2, then the period is faster. The frequency is faster, so the period becomes pi. Is that okay? And when B equals half, then the period is become 4 pi. It's actually horizontal stretching. So here, these two equations for period and amplitude are very important. Amplitude, see where? Amplitude, see this value. amplitude is related to from 0 to 1, this value is called amplitude. So if you time 2, you become this. Time minus 2, it becomes this. But the amplitude, both 2 and minus 2, is 2. Period is talking about how long it takes for one cycle, for one full cycle, from here to here. Well, for one cycle. Standard sine x is 2 pi. And then standard 1x is 2 pi. 2x is half pi, 1 pi. And then half x is actually becoming 4 pi, make it stretched. So these are the concept for amplitude and period. Is this okay?
Yeah.
So that's if we use sine x, the period will be 2 pi. Sine bx, the period will be 2 pi over b, right? And b greater than 1, it will be compression, and then the frequency go up, the t go down, right? Because f and t's relationship is f equals 1 over t, and then t equals 1 over f. That's the relationship for period and frequency. Okay, but here if we have sine 2 pi f times x, and if f equals 1, then the period is how much? If f equals 1, period is 2 pi divided by 2 pi, it equals 1. So sine 2 pi x period is 1, or t is 1. Is that okay? Because sine x, you have the period of 2 pi, but you speed up by a factor of 2 pi, then your period is only 1 original 2 pi over 2 pi, it becomes 1. So for this one, we call it for sine 2 pi x, and if x is 1 second, we call it 1 hertz. Hear about this word before? Hertz. That's 1 hertz. Let me clean this. Let me take a picture actually. That's called 1 hertz. Let me clean this. Okay, now I close this. Let me go to here. Let me clean this one. Okay, now let's get started from standard form. Standard parent form, f of x. I'm sorry, I don't want to use this anymore. Clean. Wait, how come it won't go? Wait. This one doesn't want to go. Oh, let's belong to this one. Let me make it smaller. Okay, here. Now, our standard form y equals sine x. This guy, period 2 pi. Frequency is 1 over 2 pi. I'm sorry, 1 over 2 pi. Y equals sine 2x. The period, this one can also call period, is actually pi. Frequency is 1 over pi. Sine y equals sine 2 pi x. The frequency period is 1. The frequency is 1. So 1 second versus 1 hertz. The function is like this. So when we have y equals 2 pi sine 2 pi fx. This f is called the per second frequency. So 1 per second is called hertz. So we have like 60 hertz is 1 per 60 per second. Now we keep hearing 5 gigahertz, right? We keep hearing 5 gigahertz. This is 5 times 10 to the power 9 per second. So you are transmitting your wireless phone, your cell phone, iPhone is sending something like this. Totally, there are 5 giga sine wave from one cell phone to the base station. That's how fast it is. That's how fast it is. That's called frequency. Let's type this frequency for Wi-Fi. Frequency for Wi-Fi, we have 2.4 giga several band. Right here we have a lot of different band. You have 2.4G, you have 2.5G, you have 5 gigahertz, you have 6G, you have 60G. The one we talk about for wireless communication is all related to the hertz, gigahertz. Giga means 10 to the power 9. Okay, and each one you have a channel. When we talk on cell phone or Wi-Fi, like our wireless LAN, right? The signal you send out actually take only one channel. So I may be using 2001, 2004, 2401 channel, and you talk to another person, use your cell phone in different band. And we actually won't have trouble. You talk on your channel, I talk on my channel. And both of us are fine for that frequency. That actually is the communication frequency. And here for our system, these are called the stretching, horizontal stretching. And when F become bigger, the cycle will go down. But the standard form, the period is 2 pi. Frequency is 1 over 2 pi. 2, it will be pi and 1 over pi. And then 2 pi f, when f equals 1, you have 1 hertz. F equals 10, it will be 10 hertz. And then if you have gigahertz, that's 4 gigahertz. Right? And then the basic knowledge, these are actually related to physics. This is related to physics. So a girl is singing some song, the frequency is going from where? From about 20 hertz to 20,000 hertz. Okay, that's the audio band. That's when you play music, when you say something, the audio band is about 20 hertz to 40K. So that's the vocal band. So if you when you trust me by saying something, so the audio frequency. Audio frequency. Here is the frequency. Okay, so the base is from 20 to 100 hertz. Upper base is 200 hertz. Okay, and this one. Okay, up to 2K, over the 2K is called supersonic. So 20 hertz to 20,000 hertz is actually audible range, audio spectrum. This is called, frequency is called spectrum. So this is audio spectrum. Now, here we also have the visible light frequency. Okay, and visible light frequency, we have the rainbow color, and rainbow color red is 4.3 10 to the power 14 hertz. It's way very high, okay, compared to the audio. It's way very high. That's the visible light frequency, okay. And all the things we are studying actually are all called sine wave. And sine wave have a special name called sinusoidal function. Sine wave have a special name called sinusoidal function. This is called sinusoidal function. And sinusoidal function is the one we are talking about right now. Sinusoidal function has the amplitude that is changing the amplitude. Sinusoidal function, you have the amplitude, is how tall it is, how fast it is, it's called frequency. When you have a shift to the right, to the left, that one is called phase shifting. So we are actually discussing the sinusoidal wave for those different transformation. Let me see, one moment. I'm not in here, in the other one. We are. So this is the, let me see. This one. The A is amplitude, making how tall it is. B is the frequency, making how fast it is. The C is the shift to the right, you have the positive C. Shift to the left, you have plus C, and that is going left. And D is vertical shift, moving up or moving down for the sine function. Okay? That's the transformation we have for sine wave. And that D actually also has a name called mean line, the middle line. When you shift up, you add the D for 2. The mean line is 2. And if D equals 0, is middle line is 0. Okay? So this is the sine wave shifting. So here, actually, this one, let me see. I'm sorry, I'm trying to bring up Ashley's textbook. For Ashley's textbook, we cover this frequency and amplitude. And this one, graphing the cosine, we showed it already, right? And this one, when your baseline, middle line move up, the amplitude. So like this one, let's study this one. The top level is 5, mean line is 3, so amplitude is 2, right? Amplitude is 2. And then this is a sine wave. This one is a sine wave. And the baseline move up by 3. So the function for this guy, the function for this guy apparently is a sine function, right? Frequency, the one cycle is what? Half pi. One cycle is only half pi. Our original function is 2 pi. So it's actually half pi over 2 pi is a ratio of 1/4. So actually here actually is 4x. So this one actually is a sine 4x, right? Amplitude right here is 5 divided minus 3. So actually the amplitude is 2. Original value should be 1, right? And then you move up by actually 3, so it's plus 3. So this one is plus 3. So the function for this guy actually is y equals 2 sine 4x plus 3. Okay. Okay, let me clean this one. Now, let you work on the next one. You guys work on the next one. I cannot see it, but you try to create this one. Try to create the next one. We have 5 cosine 1/2. 1/2 is what? Frequency is only 1/2. So it actually make it wider. And then x shift by 3 pi. Can you draw this function? Okay, let's look at the chart. Okay, probably I'm not able to see you anyway. So there's no middle line. The middle line is missing, so your middle is 0, right? Now the amplitude is 5, so the top level one is 5 right here, right? And then the next one, the frequency is actually 1/2. So one period is actually 4 pi. So one period is 4 pi up to here, right? Now it's cosine function, and then it's cosine function. I'm sorry. It's a cosine function. It's a cosine function. Amplitude is 5. And then actually frequency is actually what? 4 pi. So up to here is 4 pi. Right here for one cycle. But again, this one, actually the frequency is 4 pi. And then it's shift by 3 pi. Shift by 3 pi, so actually it's shift by 3 pi to the left. So to the left, so it actually shift to here. So actually starting from, let me see, it actually 1, 2, 3 pi, this is actually 2 pi over here. And 3 pi is to this point. And it actually is shifting right. So actually, because it's shifting right, so let me change to red color. Shifting right, this top value should be here for 3 pi, shift to here. Now, so actually is actually also equivalent to move left for a pi, so it's something like this. Okay, that's how you come up with this chart. Okay, so this one probably need to make more practice on graphing this. Reflecting sine cosine, reflecting is not hard. Reflecting you just actually need to just bend over the y axis or x axis. Finish the original one and then map to the y or x. Okay, this one is not hard. This one is about the phi is a periodical function. Phi is a periodical function. Now let's look at a periodical function. What is a periodical function? A periodical function is defined as this. We have the definition. It's a periodical function. Over here, this one is periodical function. When you, whenever you have a plus p and then shift left to p or shift right to p, that p will have the same value. You repeat the same value every period. That is a periodical function. So let's look at the textbook. This one is a periodical function. So every a period is from peak to peak. That is 3 minus 1. The period is 2. This one is also a periodical function. So this starting point here to here. So it's half pi, 3 half pi, and then 2 pi. So the period is 2 pi for number 6. This one is not periodical function because it's not repeating the pattern. This one growing is also not periodical function. Okay? So periodical function is every certain period you have the same value. That's called periodic function. And the way to find a periodical function's period is you find peak by peak or valley by valley or midpoint by midpoint. And you have to make sure that it's repeating every same period. And then the first one that repeats itself is called fundamental period. More than that is actually called second period, third period, something like that. Fundamental period is the smallest period. And the amplitude is actually the maximum value minus the minimum value divided by 2. So for our sine wave function, maximum value is 1, minimum value is -1, maximum minus minimum is 2, divided by 2 is actually 1. So that's the amplitude you have from here to here. Let me see, and then it's all exercise. Okay, then this section 4 is pretty much done for your textbook. Now let me see. Chapter 9. Common Core High School. We finished this trigonometry ratio function. Phi, cosine, sine, we finished. And then the next one is other trigonometry function for tangent, cotangent, those kind of things.